This video is done for the second year batch for the Metamorphism, and as it is, we are inside the problem of the lockdown. Okay, so previously we have discussed about the certain things like metamorphism and how metamorphism can change the mineralogy of the rocks, and as well as we have discussed regarding the generation of the minerals or mineralogical assemblages like sterolite or garnet, and why aluminous phases can be generated due to the metamorphism of peltic rocks. And we have also discussed that how why the mineralogical transformation can take place in geochemistry as well as metamorphism, the role of chemical potential. We are going to have some idea when I am going to give the new video regarding this in YouTube, like the role of chemical potential in the metamorphism or determination of the metamorphism. We have also discussed about the role of differential stress regarding, not pretty much of discussion because metamorphism does not care about the Helmholtz free energy. So obviously we are going to deal with the other type of the metamorphism. I mean thermodynamic parameters that discuss about the metamorphic processes. Now, we have also learned how the migmatites can be generated, the different textures of the migmatite, that is nebulitic texture, like paleosome, leucosome, melanosome. You have also seen them in the field. Now, the last day we have also discussed about the different diagrams, that is ACF diagram or AKF diagram or AFM diagram, or in which points or in these diagrams where a theoretical mineralogical formula or the mineral can be put, that is whether it can be put in the apex, whether it can be put in the line, or whether it will be put in the field. I remember you guys were fumbling apart from Kelvin, so that was up to your task, that the texture of the metamorphic rocks as well as the texture under microscope of the metamorphic rocks as well as the ACF, AKM and AFM diagram. Please remind me if I am missing something. As well as in previous semesters we have also gone through the metamorphism in its the role of the Gibbs-free energy in determining the metamorphism. Chemical potential related, the video I will be uploading soon. You have also heard the terminology called the liquid percolation threshold or rheological critical melt percentage, etc., and how the melting of different rocks can generate different proportions of the melt, and those melts might flow in and out of these situations. Now, my question is that suppose I am trying to increase the temperature of a rock which has silicon percentage of 50 and magnesium percentage of 4 and etc. However, another rock which has compositionally silica that is like 75% and the magnesium is much lower in concentration. My question to you, why should the melting point of these two compositions change, or what are the principal factors that can change the process of the partial melting? Now you will have to answer this from the logical mind, that how the compositions can change the mineralogical chemistry, and the mineralogy of the rock can change the potential the potential outcomes from the partial melting of the rock. And you will have to write it down in terms of the Gibbs-free energy, in terms of the mineralogical change, and in terms of the melting point of the particular rock. As well as you can also run a perplex by downloading this from perplex.edu, the site of the Jad Connolly, and then you will see, as you can see in my video, that how the compositional changes of a bulk can significantly change the composition of a partial melt in a different pressure and temperature. So I am uploading this right now. However, tonight I am going to upload the video about the chemical potential. Okay.